Alright, so to apply computer engineering to our everyday lives, let's start with a quick look at the main systems that will be the foundation of our discussion. The two key players are, as you saw in the title, the human brain and the computer CPU. The CPU is often called the brain of the computer because it handles crucial tasks like thinking and problem solving. While both systems process information and execute instructions, the truth is, the actual structures of the human brain and the computer CPUs are fundamentally different. Our brain is made of an enormous network of around 86 billion neurons and 100 trillion synapses. These vast interconnected structures operate through a parallel processing, firing up signals widely and simultaneously instead of focusing on just one spot. This is why you can experience multiple senses at once or have complex thoughts all happening at the same time. A CPU, on the other hand, operates around a few powerful cores. Think of it like a methodical genius. It's a centralized system that follows a strict set of rules to perform complex logical calculations with incredible speed and precision. It's optimized for handling complicated tasks in a precise, step-by-step manner. So while both are information processing devices, their purpose and structures are fundamentally different. However, the problem we are here to solve today, managing multiple tasks within a limited time, is much closer to a computer system scheduling and prioritization challenges. And it's in the area that the CPU structures has a clear, powerful advantage. That's why we're borrowing from the efficient principles of the CPU to apply them to our own lives. So before we get into the optimization methods, let's take a moment to understand the real-world constraints and conditions we're dealing with. Think about it. We can breathe and blink and move our fingers all at the same time, right? Our brains are very well suited for the kind of low-level parallel processing. But what about this? What if we try to drink coffee, sprint, drive a car, and play a video game all at once? That's completely impossible. This is because when it comes to conscious tasks, our brains can handle them in a parallel. Instead, we have to switch between them sequentially, much like CPU. In computer science, this process of a CPU switching from one task to another is called context switching. Even from a computer's perspective, this is a phenomenon that lowers work efficiency and consumes a lot of unnecessary energy. Likewise, if we try to jump between several tasks that requires higher levels of concentration, like writing a report, intense exercise, and gaming all in a short period, what happens? It ultimately leads to a drop in focus, CPU fatigue, and a huge amount of overhead. So, to maintain our focus and improve our performance, we have to remember to avoid frequent context switching as much as possible. Now, I'd like to introduce the optimization framework I actually use in my daily life. These principles are designed to eliminate complexity and maximize productivity. You could say they are the core engine that drives the system of my life. This framework is composed of three key pillars. The first is priority control. We receive countless tasks every day, and the core of the principle is deciding what to start first and what to push back. This goes beyond simply creating a to-do list. It's about clearly ordering tasks by their importance and urgency, and having the courage to boldly deprioritize to focus on what truly matters. This is the beginning of smart scheduling. The second is scale up. A single computer has its limits on how much workload it can handle. When its performance isn't enough, two common methods are scaling out and scaling up. Scaling out is about adding multiple servers to distribute the work, but since we can increase our bodies or brains, we have to adopt the scale-up method. Simply put, it's the concept of upgrading a computer's performance, just as a high-performance computer can handle the same amount of work better. It's the same for us. So I've interpreted this concept as strengthening our resilience and pain threshold. I'll cover this in more detail when I have the chance. The third is automation. Repetitive tasks waste energy and steal valuable time that could be spent on more important things. Automation is a principle designed to solve exactly this. By automating standardized tasks and decisions, we create the space to focus on high-value work. This isn't just about saving time, it's a way to fully unleash our potential. Now it's time to talk about the specific methods for the first principle, priority control. Don't just see your to-do list as a series of sentences, list this as they came to mind. If you simply list them, it's easy to handle whatever catches your eye first, without considering its importance or urgency. From now on, try using a priority queue, which is a wasting line structures where a CPU places tasks after judging their priority, and your role is to become the scheduler who makes the wisest decisions about which of those tasks to handle first. The criteria for judging priority are as follows. Schedule tasks based on importance, why you have to do it, urgency, by when you have to do it, and impact, how much positive value it creates upon completion. Once you've set your priorities, the next step is to secure uninterrupted time with your one wheel. Fully secure a specific period for important high-value tasks that require deep concentration. No other process can intrude on this time. In computer science, this algorithm is called non-preemptive scheduling. But reality isn't always as we'd like it to be. Unexpected external variables always exist. In such cases, you also judge the new task by the same priority criteria and decide where to place it in the predefined priority queue. You then switch and handle it as needed. In computer science, this is called preemptive scheduling. Thus, we approach this with a hybrid scheduling model that combines both non-preemptive and preemptive methods. Your priorities aren't fixed. They need to adapt fluidly based on importance, urgency, and impact. By adopting this hybrid model, we get a sophisticated operating system for our lives, one that allows a high-performance CPU to process the most important tasks first while maintaining stability in unpredictable situations. Is simply mastering priority control enough to solve our problems? Unfortunately, no. Our daily lives are filled with countless distractions and traps that steal our focus. Or, even if everything seems important, we have clear physical limits. That's why another powerful optimization strategy we must adopt is deprioritization. Think of your brain as a CPU. When it gets overloaded, its performance drops sharply. The most powerful way to maintain fast execution speed is to clean up unnecessary background processes. Choosing not to do something is a core strategy. For a concrete way to approach this deprioritization, you can apply the 4Ds of the Eisenhower matrix to further optimize your productivity. First, do we first execute the most important and urgent task immediately. Defer, this means delaying tasks that don't need to be handled right away. Delegate means assign tasks to others so they can do them and save your resource. Delete, this means boldly eliminating unnecessarily low-value tasks. This isn't just the act of reducing your workload. It's a way to secure greater speed and space by focusing all your energy on what is truly important and urgent. Yeah, so we've talked about priority control and process scheduling, and now it's time to discuss time blocking, the most effective technique for applying these concepts to your daily life. Time blocking is a scheduling technique that involves assigning specific tasks to a particular block of time. It's more than just a list. It's a strategy to set up each time block as a cue to focus all your conscious effort on a single area. What would happen if you had a critical 2-hour task but decided to split up into the 1-hour chunks, mixing them with other tasks? The context switching cost would skyrocket and your efficiency would plummet. Therefore, the goal of the time blocking is to group tasks of similar types and nature ensuring you can achieve deep, focused work. For example, you could assign a specific color to your schedule for different types of work. Use blue for tasks requiring deep thought, like writing a report, and green for quick communication like emails and messages, minimizing the cost of switching your brain's context. There is no perfect one-size-fits-all schedule. The most efficient approach depends on your role. For example, if you're a developer or an engineer working on project timelines, you can break down your roadmap into detailed actions and schedule them to maintain control over your progress. But if a role requires quick communication, like sales representatives or customer support, it's smart to set aside flexible time slots to handle unexpected interactions. Remember our previous discussion on non-preemptive and preemptive scheduling. Time blocking allows us to use a hybrid of both. Non-preemptive slots is secret time that can be interrupted for important tasks that require deep focus. It's best to use times of day when you can concentrate best, like early mornings or late evenings. Preemptive slots means leave flexible time to handle unexpected tasks or sudden requests. When a new task comes in, you can decide based on its priority where to place in one of these open slots. The most important thing is to remember is that this is a methodology, not a rigid rule. If you become a slave to time blocking, you will lose flexibility. It's not about scheduling every tiny detail, like 9 a.m. to 9:30 a.m. for email, or 10 a.m. to 10:05 a.m. for a bathroom break. That's missing the point entirely. The goal is to secure time to focus on high priority tasks and use the rest of your time flexibility. One final tip is interrupt batch processing. A modern operating system doesn't let every small process interrupt the CPU. It puts them in a queue to be handled all at once. Likewise, you can minimize frequent switching costs by dedicating a specific time to handle all your small distractions like email and messages. Ultimately, time is no single right answer. The key is to find the optimal method that works for your one situation by calculating your personal peak focus time or priority task, etc. We have reached the end of our journey in applying the principles of computer engineering to the complexities of our daily lives. This is a summary of the core principles and specific methods needed to optimize our lives as an efficient system. Think of it as designing a high-performance operating system for your life. Priority control, this is the first step toward a stable system. It's about actively classifying incoming tasks and information and taking control to decide what to handle first. This is a fundamental principle for focusing your energy on what is most valuable. Scale up, this is the concept of upgrading your system internally. It means building your own resilience and increasing your capacity to handle more workload without external help. It's about continuous self-improvement to become more capable. Automation, these principles, is about removing repetitive and inefficient processes from your system. By automating standardized tasks and decisions, you save unnecessary energy and free up time to focus on more important creative work. Priority queue scheduling, this redefines your to-do list not as a simple list, but as a priority queue. You evaluate every task based on its importance, urgency, and impact to determine the most efficient order or execution. Hybrid scheduling method. This is the smartest way to deal with an unpredictable reality. You combine a non-preemptive approach for focused, planned work with a preemptive method for flexibly responding to sudden requests, allowing your system to maintain both stability and efficiency. The cost of context switching. This is the biggest enemy of your system's performance. It refers to the unnecessary energy drain and loss of focus that occur when you switch between tasks frequently in short periods. Deprioritization. This is a core strategy for reducing the cost of resources. It's the courage to boldly let go of low-value tasks rather than trying to do anything. For this from the Eisenhower matrix, this provides a practical methodology beyond deprioritization. You effectively classify and organize all tasks into four categories: do, defer, delegate, and delete. Time blocking: this is the most powerful tool for applying all the principles in the real world. By dividing your time into dedicated queues, you reduce frequent switching costs and ensure your system handles the most important work efficiently. Thank you so much for taking the time out of your busy life to join me on this journey. We all live in a constant flood of endless tasks and responsibilities. Sometimes we feel exhausted and overwhelmed, unsure of where to go. It's not because you're weak, it's simply because your precious systems was temporarily overloaded by a workload that was too much to handle. But now we have begun to understand the operating principles of that systems, and we are no longer passive beings who are just being dragged along. These principles are not simply techniques for handling more work more efficiently. Their true meaning lies in having an operating system which is designed for our life like a work of art and creates meaning by focusing energy on what is true most important. Ultimately, our goal is to find our authentic selves by choosing what is truly meaningful amid the chaos of a busy life. Thank you once again for joining me. I hope this small wisdom brings greater stability and meaning to your life. I encourage you to continue optimizing your wonderful system.